Hello everybody, and welcome to our last webinar for 2023. Today I have the pleasure of Nicole's company, who's going to run us through root cause analysis application, going through some terminology, and then jumping into some of the XMPro specific pieces. Can you drop to the next slide, please, Nicole? You can just pull the whole slide. Some of the areas that we're going to cover is she's going to run you through what is a root cause analysis, some types, some benefits, an XMPro blueprint around root cause analysis, and then we're going to touch on at the end there just our general blueprints, accelerators, and patterns as well. Next slide, please. So it's my great pleasure to introduce to you our one of our resident engineers, Nicole. So Nicole, if you could just give everyone a brief introduction, and the floor is yours.
Sure, thank you. So my name is Nicole Scheinbach. My background is in mechanical engineering. So a little bit just about my previous roles before being an engagement lead at XMPro. I was a reliability engineer in a polymer facility. Primary responsibilities included PM improvements, PM reviews, equipment upgrades or modifications based off process changes, as well as root cause analysis. I also was a remote process engineer that specialized in asset condition monitoring. This was primarily through the use of IoT sensors that track vibration across. Personally, I was over 15 different building product and paper mill facilities, trying to prevent unplanned downtime on their equipment. So my current role is an engagement lead. I've had a number of clients, including Weir Nutrien, and so the primary focus of to create use cases to basically capture and codify SME knowledge, to ensure it's not lost, especially when people retire, as well as to enhance and streamline current workflows to solve any sort of problems that clients may have. So some basic terminology alignment. So first of all, what is a root cause analysis? Most people are familiar with this term, but just to clarify, so root cause analysis is a root cause analysis aims to identify the causes of a problem in order to identify actions to help solve the issues. So at a high level, right, you want to be identifying the actual causes of a failure, not necessarily the symptoms. As shown on the diagram on the left, right, the symptoms are typically what you actually see, i.e. a pump bearing has locked up, but why has the pump bearing locked up? And so through the root cause analysis process, the aim is to address these causes and not necessarily just the symptoms. Next, going into the different types of root cause analysis. So there are many, many types of root cause analysis. We're going to focus primarily on the ones that are of the cause and effect type analysis. I listed here 3 that are quite popular. The first is the 5 why approach. This is what our solution is loosely based off of, and we'll go into that once I launch into the demo. At a high level, 5 why is an iterative technique to explore the causes and effects of underlying certain issue. So usually people describe this as when a child basically asks, why something has happened, and they continually ask why. Eventually they give up or they get the answer they want. In the same fashion, right? If you keep asking why, you're going to get more and more into the details of a problem until you actually reach the root cause. Next, we have the fishbone diagram, also called the Ishikawa diagram. So this is a visual method to organize the cause and effect relationships into categories. There is a little fish on that diagram to the right. That is typically what the structure does look like. The head is typically the actual problem. And then the associated bones are the different categories of causes. So this is used across multiple industries, and there's different mnemonics that people typically use for the categories. One common one is the 6M for manufacturing. There's also, I believe, a 4M. There's different M categories based on how many categories you want to go through. The 6M is basically manpower, method, machine, materials, Mother Nature, and measurements. So that's a good starting point when your team wants to start putting associated causes underneath a larger category. Finally, there is the Pareto chart. So the Pareto chart aims to identify the frequency and impact of a problem. It sometimes follows the 80-20 rule, where most problems, 80% of the problems are caused by 20% of the causes. And so in a Pareto chart, you're looking at the leftmost of the chart basically, which is, what issues are happening at a high frequency as well as causing the most downtime. So typically, my experience with this is that at the end of the year, it's a good look back of a cumulative impact. So my reliability engineer would usually sit down our team, right? Go through basically, look, this is the frequency and impact of some issues, and try to assign work accordingly for the next year to address those. Next, benefits of doing a root cause analysis. So why would you want to do this, right? The main benefit to doing this is to prevent reoccurrence of issues in the future, right? The whole goal is basically X, Y, and Z happened, causing a failure, right? So you're wanting to create action items to resolve the root cause of a specific failure versus the symptoms. Again, referencing the tree, right? The symptoms are what you visually see or visually happens, and the root cause, that's what you need to identify and resolve. Additionally, improved team communication. So, working with your colleagues, there's multiple disciplines, there's, a cross-functional team that, provides support for the whole process, right? So you need to ensure, first of all, that the full picture is captured, right? So you want to involve as many relevant people as possible in your RCA process. So everything that is relevant is captured, understood, and addressed via team collaboration. You also want everyone's input to ensure everyone is on the same page and agrees what the steps are to ensure this problem does not happen again, right? Everyone needs to agree. Finally, in terms of documentation, right, this documentation is important. You first want to, validate that you have done your due diligence. You've captured all the associated data and evidence, as well as associated action items to, close the loop and ensure this doesn't happen again. And this is also a great way to share across your organization. So if you're in manufacturing, typically you're going to have, associated sister sites that are doing a similar process to you, which might have the identical equipment. So ideally, you're wanting to share your experience with them. Obviously, not a great experience, but to ensure that this doesn't happen to them again, right? Or doesn't happen to them in the same way that the failure has happened to your site. Now, in terms of the right diagram, so this is sort of how the different steps and pieces that you need to fully complete an RCA. The first is the problem identification. So basically what has happened and how you're going to, capture that. So, X, Y, and Z failed at this time and this impact. The next is the data collection portion. So this is an important portion where, again, utilizing your cross-functional team, you want to be gathering all the necessary data. So, PM plans, operations routes, process data, anything of relevance to your failure, you need to capture in a timeline so you can see, potentially when the actual issue cropped up. Next, cause mapping and identifying the root cause, right? You're actually performing the root cause analysis and identifying what the issue is. Finally, closing the loop, you need to create actions that are addressing the root cause or causes and ensure that they are implemented so this issue does not happen again. So how does this process integrate into our XMPro existing process? So typically, depending on the client, there may be a very specific use case or problem that they want to address, or it might be something more broad. For example, reducing unplanned downtime, right? That's quite a broad statement, and that's something obviously very common amongst sites. You want to ensure that we're trying to identify the right items to address this issue. So typically we go through this process of we first identify, the bad actors, right? You can do that essentially via Pareto chart. You want to identify ones that are, either frequently failing or causing a massive impact on production or operations. Next, you go into the failure modes, right? What is actually causing this bad actor to fail? You need to identify that to properly address it. And then, coming into the root causes. So again, identifying the root causes is the most important part, because if you don't identify the proper root causes, you're not going to be addressing the correct problem. Now, items to the right basically, is the rest of our process here. We identify, now that we know the root causes, any of the leading indicators, what data sources we need to integrate with, and then, associated recommendations with that. So today, though, we are going to be focusing on the root cause review. So we wanted to bring this blueprint essentially to make available to people, because basically we have, implemented solutions for clients. We now are enabling, clients and, even new clients, right, to utilize our root cause analysis application to identify, what kind of root causes are creating potential, downtime, availability losses, anything like that. You can utilize our platform to create solutions to address these issues. The XMPro-based root cause analysis application. So now I'm going to take you through the actual demo, and you can see kind of what we've provided in terms of a blueprint. Second, as I bring up this demo. All right, so we have here the demo. So I'll quickly go through the basic pieces of this landing page. So you'll land here. The first part is the left, the number of failures per asset type for the last 12 months. So this is based off ISO 224, which is actually the structure that we've utilized to create our variation of the 5Y. The ISO code basically goes over how to capture data in a quote unquote like reliability format, to ensure when you're doing an analysis, later in the year, everything's captured into, appropriate categories so you can analyze in the future. This is used across multiple manufacturing facilities, as well as, different equipment types. So here for our sample, right, we have centrifugal pumps. We have the broad categories for failure mechanisms as electrical failures, external influences, material failures, and mechanical failures. Now coming on to the right card, action items due soon. So this is at a high level, everything that all the RCAs that you've created, all the actions that are due. So, this is great if you need to look up, potentially one that you have been assigned to, double checking which ones you have and when they're due, or at a high level, perhaps, maintenance manager looking at all the associated action items that need to be due and doing any sort of necessary follow-up. Finally, we get to the bottom card here, the all root cause analysis card. So this card allows you to actually go through and look back at your existing root cause analysis, look at any pending action item, just look at any of the timelines, anything like that. Once they're completed, they will be stored here. So again, for documentation purposes, you can reference them in the future. So right now we're going to go through and create a new RCA so you can just see the general process. So first, as mentioned in the PowerPoint, the failure details. So we just want to capture at high level, first of all, what has happened and the associated financial impact, right? That's the most important thing. You typically do root cause analysis for, extremely high impact things, that you need to address. So for this demo, we have centrifugal pumps as the asset type. Now, going forward, you can add any associated asset types that you want. So if you've got heat exchangers, fans, anything of that nature, you can add a structure in there to add them just to your RCA application. I'm going to go ahead and just copy and paste some of this data in, so you don't have to watch me type here. So we have a asset ID, equipment ID, and what basically happened. So there was a pump and it was shut down due to a high overall vibration in the DE bearing. So this happened the beginning of the month. So we're now trying to evaluate it while everything is fresh. Facilities. So this fictional client is based out of Texas. and they have basically 2 areas of their facility. In terms of safety impact, there was no safety impact, a bit of operational impact, and a larger production impact here. So after completion of all these fields, it will automatically sum up. Double check all your items here, and you can click Save and Continue. So, apologies, I did not add a 0 there. There is some validation on these fields. These fields are required, so you do need to fill them all in. This is all necessary information. Going on to our next phase, timeline. So this is the data, collection portion that's really, vital to your cause mapping, right? You need to identify all the associated events that could have accumulated in your failure. Now, if you also notice up here, there are associated breadcrumbs. This provides additional navigation between the pages, as well as lets your team know essentially that this is how many parts you still have to do to complete your RCA. So coming back to, you have your cross-sectional team basically available, and they're digging through, and they've noticed that way back in June, right, we installed a new assembly. And this was of normal maintenance. There was an overhaul, and we just we installed a new rebuilt assembly here. Digging through your CMMS records, you notice that unfortunately here there was a failure, and it was all hands on deck. The failure of a fan, and unfortunately a scheduled PM was not completed. So this was for lubrication of that pump. Now, a couple days later, there is also a scheduled vibration route that's done. It does not pick up any sort of anomalous overall vibration yet, right? Maybe, the bearing is still okay at this point. Now, unfortunately, these lubrication PMs and BiPEC routes, they only happen every couple of months, right? So everything looks to be okay until an operator basically comes up and he's doing his normal routes, and he can hear something wrong with this bearing. At that point, it's too late, right? Your bearing's probably done. What he does is he tells his manager, and his manager basically calls up the reliability and maintenance team, and they take another reading, basically before the scheduled reading. Basically, on the day that it's taken down, the BiPEC comes and says, look, this is a stage 4 bearing failure. At this point, you need to shut it down. I have no idea when it's going to fail, and we don't want to just have a random, unplanned downtime in the middle of the night when there's no support. So your cross-sectional team has basically gone through and put together the series of events. They think that, this is good enough. We think we have an idea now of what would have caused this issue. Now, we still need to capture everyone that has participated. So, obviously for documentation purposes, you want to capture everyone that is part of this. First of all, we have Bob Costa. Bob Costa is a process engineer. We also want to capture well. You want to capture this for documentation purposes, but you also want to ensure that everyone here is captured, because when you assign the action items, you can only assign the action items for people that were captured here. So again, you want to make sure everyone is captured here. So we next have Jill Smith. She's a reliability engineer. She also works at company. Last but not least, we have Max Boberson. He is the maintenance team lead. So he has provided his input into this RCA, and he is Boberson at company.com. Okay, so now we have our participants, now we have our timelines. We want to go ahead and save and continue. As we go to this part, someone says, oh, I think I need to revise part of my timeline. Okay, so we go back via the breadcrumbs here, and he says, I want to make it clear that my operator, he informed me ASAP, and we tried to get this done as soon as possible. So we want to add an additional note here. It says, operator notified manager immediately. Spell. Okay. So there is a couple additional functions here. One of them is the save button. So you can see the save button is to the top right of each card. If you do need to make modifications, you can go ahead and do so. After a certain point in the RCA, you'll no longer be able to make modifications, right? For documentation purposes, people can't just come back and continually make modifications. But at this point, right, you haven't done the cause map, you can make modifications. You can also delete, and I don't necessarily want to delete here, but if you click here and click delete, you can, delete anything. Maybe you're doing a revision with your team and you decide, oh, this event actually didn't happen, or potentially we need to shift around some things. You can go ahead and delete and upload the necessary information. But we're going to go ahead and save and continue. So coming onto the failure analysis part, right? So this is the most important part, right? Ensuring that you capture the correct failure analysis, as well as identifying the root cause, so you can have corrective actions to take. So what failure mechanisms? So again, utilizing 14224, the ISO code, right? There is high-level buckets that we want to place these in, again, for documentation purposes in the future. So this overall vibration, causing a bearing failure, that would typically be considered a mechanical failure. What kind of mechanical failure was this? Well, it was related to specifically vibration. And then why did this happen? So what caused, what did the vibration do essentially to kill the pump? And in this case, it created a bearing failure. And the bearing failure was essentially going to freeze up the pump, and the pump was going to stop rotating. So after this part, you're saying, okay, so the failure mechanism, which is at the highest level, what you visibly see is that the bearing failure due to vibration caused the pump to fail. Now, what kind of comments or additional information can you provide? You go through and look at your system, maybe your vibe system, and you analyze that data, and you find that like in your timeline, that these bearing readings indicated a stage 4 failure, and then there was indication of BPFO. So basically at this point, your vibe tech has recommended, please, shut down. Again, we don't want unplanned outages. Again, this is kind of like the higher level, what you actually see. Now we come down to the actual failure causes, right? So, the bearing, unless there was a manufacturing defect, right? The bearing just doesn't fail by itself. It has some help here, right? So in terms of what we've dug in through the timeline, basically it looks like a PM was missed. And don't know if it's like within the system, if there's some way to, ensure the PM is done, but essentially the PM is missed, right? So that is kind of a failure related to like the management, the workflow system, right? Something is not aligning. This is a critical piece of equipment, and when the PM is missed, we want to ensure that it is done again, right? We can't just be missing PM. So in terms of that, it's sort of a CMMS potentially, or documentation error, right? Basically, or potentially a management error, depending on which one your team goes for, basically. So the management of the PMs needs to be reevaluated. You need to look at basically how we can ensure that critical PMs are completed or rescheduled. If the potentially it was done the day after, this may not have been an issue, right? So after you've evaluated with your team, you leave some comments, basically. And apologies. So definitely because of this unplanned failure on another piece of equipment, all hands were on deck. This PM was missed, and unfortunately, because this PM only happens not on a high frequency, it was not known until basically the bearing was in a stage 4 failure that was going to cause an unexpected failure. So this is your cause map. Once you're happy with this, you can go to save and continue. And this is the final stage. This is the action portion. So you can see here, this is the cause map that you just created. Now, if you do need to modify anything, you can go back to the failure analysis tab via the breadcrumbs. But right now, you can basically take a look at this and identify what sort of actions you need to take to address this. So in this case, one of the things is that basically the PM was missed, right? So we want to identify why the PM was missed. And some notes here, basically, because this was missed, we need to discuss with maintenance how to mitigate this in the future. I guess the current practice is basically the PM is closed and we wait for the next one to come along. But for certain PMs, right, especially ones like this, that can't be the current practice. Max Boberson, he is the maintenance, he is in charge of kind of assigning the different PMs. He can take a look at how we can potentially address this in the future. We should probably give him some time, right? Probably at least a month or two, right? He needs to go back through, double check what the current practice is, and communicate that to his team. Next, we're noticing that basically because there was no continuous vibration monitoring on this piece of equipment, it was only picked up because an operator heard the sounds, right? Which at that point, it's not savable. And so, you know, we've been hearing about all these IoT sensors, right? They return real-time data. This could have potentially caught it before it became a stage 4 bearing failure. Why don't we look into some of these IoT sensors? There's a lot on the market, right? But you know, based off our process and needed temp requirements and things like that, we can probably find something that we can install on there and ensure that we are seeing the vibration data in real time. So Jill Smith, she is a reliability engineer. She's going to go through, she's going to take a look at any sort of associated IoT sensor companies that look like they could be a good fit for our application. All right, new actions. So the team has deliberated. Okay, we feel that these actions are good and are addressing the issues. Now, if we do need to come back and add actions in the future, we can go ahead if we think about something else or X, Y, and Z. Otherwise, we feel confident that this is going to address this issue. So now that you've created your actions, you're going to go ahead and return home. And now you can see that these are by RCID. You can see that this one was created, and so now you can go back and reference that in the future. All right, so that is the demonstration. Again, a couple quick items to note here. So you can navigate to the RCAs via here. So for example, if you want to see this RCA, so this is another sample RCA, you see, oh, I want to reference like what was discussed here. It might have been a while. You can go back and see based off the action items of the RCA. Similarly, you can go back and reference the RCA here. Oh, sorry. It is not the one that was created. It is, let's see, this one. Now you can basically see what the information is that was captured in that RCA. Okay, now I'm going to go back over to Gavin, and he's going to finish out this presentation.
Thank you very much, Nicole. The one thing I will mention is this is a blueprint. So what that means is if there's anything extra you want to change, you want to add to, you can adapt this to your own processes. You can change this to your own way of doing things. All the data is captured. If you can go to the next slide, please, Nicole. All the data is captured, and the other thing is, even if you flag something as deleted, it's not deleted from the database, it's flagged, so you can't actually bring it up. However, you can put a ton of metrics on top of that and actually bring a lot of that up. We will be expanding on the blueprints as well, and adding a lot of different feedback options for the reporting, etc. So where can you find it? It is part of our blueprints, accelerators, and patterns. We covered that in a prior webinar, what that is, how to access it. On that page, if you hit the landing page, bottom right, there's an RSS feed. If you click that, It'll actually give you the RSS feed you can load into your Outlook, etc. And then you can be informed whenever we publish new ones out. This particular one should be out just after these webinars, just before the holidays. And you'll be able to access it and go from there. You can also contribute to these as well. So if you have anything you feel that you need to contribute, please don't be shy. Next slide, please. And with that, thank you, Nicole, for running us all through that. This will be it for the webinars for the year. So we'll be taking a short break for all the holidays that everyone's going to go on, and we'll be seeing you in February 2024. So be safe. Thank you for the fantastic 2023, for attending, feedback and comments, and we will pick this up in February of next year. Thank you all.
Thank you, everyone.